Perimeter and area of similar figures. What happens to the perimeter and the area when a figure is similar to another figure? Do they change the same amount as the side lengths? What we found out, according to the ratio of the sides, looking at two similar figures, is that from the explorations, the perimeters do have the same ratio as the ratios of the sides. For example, if I were to show you one of the parts of the exploration here, when we increased one of the rectangles by a factor of 2, in other words, we make it twice as big each side, the perimeter ended up also being twice as big. See, the perimeter of this right here would be 2 plus 1 times 2 would be 6. So the perimeter of this is 6. And the perimeter of this would be 2 plus 4, which is 6 times 2. So that would be 12. So the two perimeters, which I should not put inside here, that's better. The two perimeters are exactly twice. One is twice as large as the other, just as the sides are twice as large, right? 2 over 4, which would be 1/2, is the same as 6 over 2. So the perimeters have the exact same ratio as the ratio of the sides. Unfortunately, that is not true of the area. Oh, that just says when the sides were doubled, the perimeter was doubled. But with the area, the ratio of the sides, it had the ratio of the sides squared. In other words, when the sides were tripled, the area was 3 squared, or 9 times as big. I'm going to show you a little example of that as well. So here's an example of the rectangle that was 1 by 2, and then when we made it 3 times as big, or we tripled it, it became 3 by 6. Now remember, to find the area, we had to do length times width. 1 times 2 means the area of this would be 2 square units. And you can kind of see where those 2 square units fall, one over here and one over here. The area of this, however, would be 3 times 6, which is 18 square units. 3 rows with 6 at each row, that's going to be 18 square units. So 2 times 9 is actually 18. So the area was definitely not 3 times as big. It was exactly 9 times as big, which just so happens is 3 to the second power, 3 squared. So the ratio for area is not just the same as the sides, but the same as the sides to the second power, or squared. Now let's use this information to show some examples. These are the notes that you should be taking down if you didn't already begin. Whoops, I'm going to have to erase that. So here's example 1. If we are given 2 rectangles, we want to find the ratio from red to blue, right? We want to write the ratio of red to blue of the perimeters of these similar rectangles. Since we know that they're similar, we can use the ratio of the sides in order to find this. So the perimeter of the red rectangle over the perimeter of the blue rectangle as a ratio or fraction is going to be the same as the sides, which is 4 over 6, reduced as 2/3. So the ratio of the perimeters is 2 to 3, just as the ratio of the sides is 2 to 3. Oopsie. Sorry about that. Notice that the ratio of the perimeter is the same as the ratio of the sides. Now, here when we find the ratio of the red to blue of the areas of similar triangles, we're going to take to find the area of the red triangle to the area of the blue, we're going to take the ratio of the sides, 6 over 10, but we're going to square it. When we square it, that just means multiplying 6 over 10 times 6 over 10. But first, they've decided to reduce it to 3 over 5. 3 over 5 squared is just going to be 3 times 3, 5 times 5, 9/25. So the ratio of the areas is 9/25. Notice the the ratio of the areas is not the same as the ratio of the sides. It's the ratio of the sides squared. By the way, if we had squared 6/10, we would have gotten 36/100, and that would still reduce to 9/25. So if you don't reduce it before you square it, which makes it easier, let's face it, then you'll still get the right answer. You'll just have to reduce it or simplify. Example 3. If we have this swimming pool and it happens to be a similar shape to this volleyball court, it wants us to find the perimeter and the area of the pool when all we know is that it's similar to this rectangle and that one of the sides is 18 yards. Well, we do know that the court is 10 yards on this corresponding side. And we also know that the area of the volleyball court is 200 square yards, perimeter is 60 yards. So to find the perimeter, we're going to use the ratio of the corresponding side lengths, 18:10, to write a proportion. So to find the perimeter of the court to the perimeter of the pool, well, that will be equal to the width of the court over the width of the pool. Those two ratios will be equal because perimeter ratio is equal to side length. So if we put 60, which is the perimeter of the volleyball court, and we put that over P, because we don't know the perimeter of the pool, that equals 10 over 18. Please notice, if we put the 60 in the top of the ratio, then that means the perimeter of the court is on the top, so the side length of the court would be on the top in the other ratio. Now to solve these, remember we can use cross products. 60 times 18 equals 10 times P. 10P equals 1080. Dividing at P equals 108. So the perimeter of the pool is 108 yards. Now the area of the court over the area of the pool is going to be equal to the square of the two side lengths, width of the court over width of the pool, squared. So when we set up our proportion here, we put 200 over A, just as we did with perimeter. We put the area over the area, and then we put 10 over 18, but before we can solve it, we have to square that. So the example has squared 10 over 18 to 100 over 324. Now we can use cross products. And if you're using a calculator, that's pretty simple to do. Even if you're not, these are pretty good numbers to work with. 100A equals 64,800, and then divide by 100, you get the area is 648. That would be in square yards for area. So the perimeter is 108 yards. The area is 648 square yards. And that's the end of your examples for your notes. I hope this helped. By the way, the more you write down of this example, the better for being able to follow this example. This is probably one of the hardest types of problems with perimeter and area that you'll have to do when they just give you a little bit of information. This is also not the only way to do it, but you do have to be careful when you're finding the area, especially.